Hello, my name is Anton Mislēvičs, and in this session we will talk about predictive maintenance, what predictive maintenance is and how it works. Here is the plan. We will first talk about what is predictive maintenance, then we will discuss who uses predictive maintenance solutions, and finally I will tell you how to implement predictive maintenance in your organization. What is predictive maintenance? When people are talking about predictive maintenance, usually they refer one of these scenarios because there is no one thing what we can tell that only this thing is predictive maintenance. So these scenarios are failure prediction, failure diagnosis or root cause analysis, failure detection, failure types classification, or recommendation of mitigation of maintenance actions. Predictive maintenance allows customers to reduce operational costs, improve service availability, and improve service quality. To better describe you what predictive maintenance is, let me show you one imaginary scenario. This is Carl. Carl owns a company that operates vending machines, and his job is to make sure that his hundreds of vending machines are selling drinks and obtaining revenue. So he wants them to work and sell drinks. But unfortunately, vending machines will occasionally break, and it may take up to 8 days to fix the vending machines, and thus during this period vending machines are not selling anything. And that's why Carl is wondering what he can do about it and how he can manage these vending machines the best possible way. The questions what Carl may ask himself are: which machines have failed, which machines will fail soon, and how do we plan maintenance? Here are three situations. First, on the left you see the current scenario. We may call it preventive maintenance. So Carl is repairing parts on some regular schedule, for example, once every year, once every 6 months. But unfortunately, in these scenarios, machines still break. And in this case, someone calls Carl and says, "Oh, we see your machine is not working." Then technician comes on site and he can detect what's wrong with the machine. Then they're going to inventory and they are ordering some parts. If the parts are not there, they're going back and they're fixing this machine. And it takes up to 8 days. Another scenario what Carl could implement is real-time sensors. Imagine they can put sensors into every machine that is monitoring the state of this machine, and if something is wrong with this machine, the sensor can send a signal that something is wrong and what specifically is broken. Then technician can go immediately to the warehouse, he can take required part or order it, come to the machine and fix the machine. And in this case, machine will be out of order for 4 days. The last thing what Carl could implement is combine these sensors with machine learning to implement predictive maintenance. In this case, every machine has sensors that are measuring how this machine is working. This data is then used to train machine learning models that can predict when something will break in this machine and what specifically it will be. And in this case, Carl can order all required parts up front, send technicians up front, and there will be zero downtime for his machines. In order to implement this predictive maintenance solution, Carl could use Azure Cloud. Imagine that information from sensors in these machines is sent to Microsoft Azure environment, it is stored there, then Carl can train machine learning models on top of this data, what he has, and then he can publish these models as web services in a web portal or in Power BI dashboard or using Excel API. Now, who uses solutions like this? Typically, these are companies that manage and rely on some assets or infrastructure. Typical examples are manufacturing industry, telco, energy, transport industry, IT industry, and many others. From real-life case studies, here are a few examples. ThyssenKrupp with Microsoft implemented predictive maintenance for elevators. So now ThyssenKrupp has elevators that never break.
As an airline pilot, I know that to fly with the best, you need to work with the best. With over 13,000 engines in operation around the globe, Rolls-Royce provides the services to maintain them at peak performance. Today, each engine has thousands of sensors that can produce terabytes of data on long-haul flights. Making sense of all that data is critical in transporting my passengers safely and efficiently. Rolls-Royce uses Azure IoT Suite to analyze data remotely and deliver real-time, actionable insights to me and to the airlines about engine performance and operational efficiencies. Advanced analytics help us optimize fuel economy, anticipate maintenance needs, and avoid costly downtime and delays. A single unscheduled disruption and its knock-on effect to a fleet and the passengers can cost an airline up to $1 million a day. With early notice, our team can proactively have parts at the right place and time, reducing inventory costs and maximizing availability. Up to 1/3 of a plane's weight is fuel. As a pilot, I decide how much fuel my plane carries. Insights into engine efficiency, weather conditions, flight path, and scheduled landings impact my decision. Cortana Intelligence helps me choose the optimal fuel level to maximize efficiency. With 40% of our operating budget devoted to fuel, even a small percentage reduction can save us tens of millions of dollars each year. Microsoft and Rolls-Royce, reaching new heights in customer value.
Now, let's talk about how you can implement similar predictive maintenance solution in your organization. Predictive maintenance is a classical example of machine learning problem. So if you are not familiar with what machine learning is and how it works, I would encourage you to look through my session on machine learning. As any other machine learning solution, predictive maintenance starts with data. You need to collect the data, then you need to pre-process this data, prepare it, and then on top of this data you can train your machine learning models, and then you can integrate these machine learning models with your solution. Typical input data sets for predictive maintenance problem are the following. As a training data, you can use machine or device operating log with run-to-failure data. For testing your model, you can use the same operating data but without failure events recorded. And finally, you need some ground truth data, what you will use to validate how good your model is trained. Perhaps as you already remember, machine learning is not a black magic. It allows you to answer few very specific questions, and based on these questions you select the algorithm, what you will be using. And in context of predictive maintenance, usually we use these two questions, how much or how many, and then we use regression algorithm, and this way we can predict, for example, the remaining useful life of the asset or time to failure. And second is which category. This is a classification problem. And with this approach, usually you can use binary classification, where you try to predict if an asset will fail within certain time frame or not. Or you can use multi-class classification, where you try to predict if an asset will fail in different time windows. For example, it will fail next week, or 2 weeks from now, or 3 weeks from now, or will not fail at all. When you start implementing machine learning models for predictive maintenance scenarios, you have two options. First option is to use Azure Machine Learning Graphical User Interface. I would say this is easier option for you. You design your model using Graphical User Interface, then you publish it as a web service and can integrate it with your solutions. The second option is much more complex, but it gives you unlimited flexibility. So you can take Azure virtual machine with GPU, you can deploy any machine learning library on top of it and start coding your models. This is how it looks. The first option looks like this. So you have graphical user interface where you can drag and drop blocks and define your model this way. The second option, you really need to write the code, execute this code, but then you can also monitor how your model is consuming resources while it's training and so on. Another thing to remember is that it's not only about machine learning model. You need to ensure end-to-end process that will allow you to get from data, what you collect from sensors, for example, to actual predictions. And then you need to integrate these predictions with some systems, what you have, or deliver it to people in some other way. And in order to do it, you can build all of this by yourself, or you can use offerings from software vendors. Here is a Cortana Intelligence Suite Services. This is an offering from Microsoft, and as you can see, it is a collection of Azure services that allows you to get from data to actions. The final thing is, how do you calculate economical effect of implementing predictive maintenance solution? Usually what people are doing, they are building confusion metrics. Here you see confusion metrics for elevator door repair prediction problem. So here you can see the actual value if the door is healthy or it has defect, and on top you see predicted value. If the model had responded that there is a defect, or that there will be a defect, or that the door will be healthy. What you can do next, you can describe what you will do in each of these scenarios. For example, you need to order a door, you need to send a technician, and you need to repair it. Or, for example, if machine learning algorithm predicts that the door will be healthy, but there is a defect, then you need to do emergency repair, and it will cost you more. Or, for example, if machine says that door will be healthy, and it is healthy, you're just saving money because you're not sending technician there. And then when you put a cost to each of these scenarios, what you can do next, when you are comparing different machine learning algorithms, you may see what is the probability, how often it gets in each of these areas. And then you can calculate what will be the overall cost saving or additional costs associated to implementing this model, and if there is a sense to implement this model. And that's it. Now you know what predictive maintenance is and how you can implement such solution in your organization. What's next? I would encourage you to go to Cortana Intelligence Gallery. What you will find there? First, you will find sample solutions for different industries. Many of them are cross-industry, and there are samples for predictive maintenance solutions as well. So you may take one of these solutions, open it up, and see what data sources are we using, what algorithms are we using, and how are we aggregating all of this together. Then we have so-called solution templates. These are end-to-end solutions. You can pick one. For example, this predictive maintenance for aerospace. This example is very similar to that Rolls-Royce case, what you've seen before. And when you select this solution, what we will do, we will go into your Azure environment and configure all services which are required to collect data, store this data, build models on top of it, and generate predictions and visualize these predictions. Finally, you can take a look at algorithm cheat sheet. This resource will help you to understand what machine learning algorithms are there and which of them should you use for different problems. Thank you very much, and good luck implementing predictive maintenance.